Everyone, today we are going to see a demonstration of the Python project. So I opened PyCharm and then navigated into assignments. Of course, I'm going to close the tip of the day, and under assignments I see the project rubrics, which is my Python project for the semester. And under project rubrics I have four modules. The first one being database, second data load, then the service, and then UI. Briefly, the sections in order are the database sections, which has the movies DB, where I'm storing all my database information, the movies information, and there's a connection object which can perform all the data access connections and inserts, updates, selects from this movies database. And there's a bunch of tests which will actually run, and those tests will actually show you like how the operations are being performed. Now then we have the data load, where I can have like bulk movies in the text file which can be uploaded to the movies database, and the dataload.py helps us in achieving that. Third, we have the service layer. The service module talks about connecting to the open movie database, wherein it fetches movie information and then uploads it to the movies database. Now this is being used both by the data load and the UI. So next, coming to the UI has the main, which invokes the front-end UI, and this enables us to actually enter the information on screen and build recommendations from the database with the movies that have been entered. So let's quickly go ahead and start with the data load operation. So what if I had like a bulk entry of data, and I wanted to build out the database? How would I go about doing that? Well, in this case, what I'm doing is a simple file read, and then after the file read operation, what the data load does is it performs the database entries if those movies were not found. And if there's a unique constraint violation, which means the movie was already found, then it leaves it alone and progresses on with the next one. All right. So here are the functions. The data load operations is a class which builds out a constructor. It reads the file, it triggers the API, and gets the information, and then it reloads into the database. So to demonstrate this, I have developed like a two-thread capability, thread T1 and thread T2, which opens up the operation A and the operation B, and then it demonstrates like if two threads were trying to do it at the same point in time, then how this would happen. So let's go ahead and look at dataload.py and try to run that. So you see, when I run it, the first one, it starts the execution. It starts the execution with operation A, and then it moves to operation B. However, since the data load has a sleep time for operation A, operation B starts first, and the operation B grabs hold of the file and then triggers the Open Movie Database API, gets all the information of the 5 movies, and then it enters into the database, and the database count is incremented. However, after that, when we move to the operation A, since it's reading the same file and not a different file, what it does is it goes to the service layer, it takes in the service, but it'll throw the exception insert table unique constraint failed in the movies database. So because of which the count remains the same, and it progresses as if nothing had happened. So even if there were multiple threads coming in and there were different files, this is what it would look like. So let's just quickly observe where the sleep time was set. So you see in operation there was a time sleep 5 seconds before the data load began, and out here the data load began instantaneously, and then there was a time sleep for 2 seconds, which is kind of not relevant in this scenario. All right, now moving to the main operation. If you run the main, it actually opens up the window, and this is a smart movie recommendation, which is more UI centric. You can enter your name, and then you can put your gender, and then you can say like, okay, these are kind of the movie nights that I love to see movies on. And then you have the action and comedy. Let's say you selected two of them as your genre that you like. Now the recommendations are going to be based on the genre that you entered. So now if I put in a movie name, it'll also build out from the movie name and try to get the recommendations from here. So once I enter the movie name and hit submit, it goes to the open movie database. It gets the information and it inserts the movie into the database because it was not already there. So that's why you see the database count has incremented by 1 to 54. And then it brings out the suggestions, and that is also logged out here. So if you look at the suggestions, these are the recommendations that have been brought out. And these recommendations, the movie name from the recommendations, are picked up, and then they are flashed on the screen. So this is where it says like, okay, these are the recommendations for you, Romit, and if you want, you can run the program again to get different set of recommendations, or you can work with this. Now, just to demonstrate like where the action is happening, this is the connector action. This is kind of the bridge between the UI and whatever is happening on the UI and then the backend operations. So in the connector action, there is the trigger API, which calls the API and gets the movie information. And then there's the trigger database feature, which goes into the database, and then it checks out if the movie already exists. If the movie already exists, then it's not going to enter the information. But if it does not, then it'll enter the new information. And then finally, the trigger recommendations. It computes like what you entered, then goes back to the database utility to get the recommendation list. And once we go to the recommendation list, it actually fires the select recommendation on the database to get the number of your movies. It also has the exclusion ID. The exclusion ID is the movie that you currently entered. So it wouldn't be a valid sequence if I said like I loved movie A and you're showing me movie A in the recommendations. So that's what the exclusion ID does. It builds out the list and then it throws it back to the front end. So the main method has the operations which calls the first screen. So the UI screen 1 is displayed. It captures all the information here. And then it goes, builds out the answers list. Then from the answers, you go to the connector action, which goes to the backend, gets the service, gets the database features out here, and then finally triggers the recommendation, and then paints that back onto UI screen 2 with the answers list. So this is the demonstration of the projects. Now a few features. The try-catch feature has been demonstrated here, and with the try-catch feature I've also incorporated the logging feature, which helps you in better logging, and this can be extrapolated to file system logging, which is very helpful when tons and tons of logs are being generated and they have to be debugged through the day, and you can put in like which file name, which function name, if there was any anomaly that was noted, and what the time would be, and what the message would look like. So all that can be configured, pre-configured. Then you have the UI sections. The UI sections have two pages, which was built using the TK Inter, and here is the first page demonstration, which pretty much has the labels, the entry boxes, the combo boxes, the radio checks, and then another entry box for the movie name. And then finally, you have the next page, which is predominantly all labels, where it's showing you all the computed recommendations from the backend and whatever information that you had entered, whether it matches the relevant information. Right now, it does nothing with your personal information. It does not save it in the database. It's only a movie database, but it can be a future scope to include all your personal details so that your recommendations can be saved with your name, and the next time you come in, we're not recommending the same movies again and again. Now moving on to the service layer, this is the service connection. You see the service URL. This is the Open Movie Database API. It's a REST service that I'm calling and using the get method only. To do the search, I'm sending in the query parameters, wherein I'm sending what is the title name, what year it was. I could send that, but I'm not sending that year because I don't know the information and I want it from the service. And in the plot, I can either make it a short or a full. Either way, it'll get you the data based on the feature name. This takes precedence. And then what type of data I want in return, whether it's JSON object or XML or CSV. And then I'm just building the service URL with the feature name and the query parameters and the service URL on top, and then firing the service on this line, wherein I make a URL open from the URL lib request and then collect the response. What I do with the response is I read the response, I decode it using the encoding type UTF-8, and then send it back to whoever is calling. And then I let them parse the information. Now, for parsing the information, I've also written a parsing utility which takes in import JSON, it takes in the message, and then it creates a parsed object. To demonstrate what the parsed object looks like, I'm also dumping this out in a JSON pretty format, wherein it takes the parsed object, it indents by 4, it sorts all the keys that were there in the JSON object, and then demonstrates in a pretty fashion. And then we have a bunch of accessor methods, which are just getters for getting the information based on the keys in the JSON string. Now, moving to the database operation, you have the DB connection. The DB connection initially has like a bunch of queries which I am going to put into the database. There are some test strings as well, which I'm going to demonstrate in a short while from now. So the test strings are for running the unit test cases. There is also a variable for a batch load, which again in this case is the test string, but this was being used from the movie names.txt in the real life scenario. Now we have a bunch of utility methods which says like once the initialization is done, it initializes the connection to the database and opens a cursor to it. Post that, you can get the DB version just to prompt it and let the user know which database they're using. There is a create table utility. If the table is not already created, you can remove the table. You can count the number of records from the table. You can insert. There are a bunch of inserts that you can do. You can insert into the table with the test, unit test. Then you can insert with a singular where you supply the parameter tuple. You can insert in batch when you can insert in the batch mode. Then you have a bunch of selects when you can select every data from the table. You can select by list of genre. You can select by the recommendation, which is a more complex kind wherein it takes in the parameter, which is a multiple string of the genre, and there's the exclusion here, which excludes the movie that has been put in from the front end. You can also select the table based on the count, and it'll give you the count for whatever genre or whatever assignment parameter that you're passing to the query. And then finally you have the recommendation list, which will send you just back the recommendation list that was prepared. And finally you have the to close objects, which is like closing the cursor and closing the connection. This is for best practices. You should not leave any of the resource objects open, which is why these utilities have been put out here. This is called after every database operation is closed. Now, so to run the test database, this is how the test database looks like. It opens a connection, does a bunch of selects, and it shows like whether everything is in order and shape or not. So if I run the test DB connection, this is what we're going to see. There was one test with the multiple criteria and all of them have passed. So it shows you like what is the database version, what are the records based on a genre, and what are the total records and total database counts in the database. So it's kind of a health check, which tells me that everything is okay. Now, if I go back to the service, I do have a test service connection for that, which will tell you, like, if I do have a movie name, Independence Day, like how I can extract out the features and show them on the screen. So when I do test service, it calls the Open Movie database, it gets all the details of the service and prints them on the screen. So hope you guys liked it. This is what my project is all about. It is basically a smart recommendation engine which has unique features, and I think you guys might have already seen this in cases like Netflix or Amazon or Hulu, wherein they can recommend the user movie features, and if they don't like it, then the next set of recommendations will not duplicate or include the previous set of recommendations. So that was my intent of building the logic, and I've demonstrated connecting to an actual REST service, demonstrated utilizing all those information and saving them in the database to calculate better recommendations, and then finally the tkinter package to show how the UI would look like on a Python instance and then show the recommendations on the UI screen. All right, thank you, and you all have a nice day.